All right, good evening, everybody. Hope you had a great weekend. It's been very hot and nice outside. Um, we have just a couple more weeks of class before we take a 3-week break. Hopefully we'll be done with this quarantine soon. We can be back in person, but in the meantime, I'm going to continue to have these videos available for you for your convenience to practice for the high school equivalency, and just hope that every little bit you can pick up on will be enough to get you to pass that and be on with your careers. So I'm gonna pick up where left off last week. I did a big unit on algebra. I think there was close to maybe 20 videos, maybe not quite that many. I'm trying to recall, but then I moved on to geometry. Geometry is another fairly big focus on the test. Just as a quick reminder, algebra takes up 26% of the test, geometry is 23. So just those two together covers half the test. So I'm focusing on just the areas that are high emphasis within algebra and geometry. And where I did geometry was reviewing the actual precise definitions of what an angle, circle, perpendicular line, parallel line, line segments, and other undefined things such as point, line, distance along a line, and distance around a circular arc. So check that last video if you haven't seen that yet. And then I did a lesson on strictly solving volume for specific things such as cylinders, pyramids, cones, and spheres. Once you have the formula, which they give you on the test, you can plug in the values that they give you and then use algebra to solve. So if you're not confident with algebra and solving equations, you need to do that before you can be confident with this, even though it's a geometry skill. I'm going to skip this low emphasis one on geometric shapes. And for this video, I'm going to focus on this concept called density. All right. I'll be honest with you, as I have in probably all of our videos, I'm not always 100% confident in my abilities. I'll try to get you through the best I can. I'm sure there are other videos out there that are better than what I have. I don't have all the technology to show you things, and geometry does require a lot of kind of concepts and really seeing things in 3 dimensions sometimes, and that's an area I struggle with. We all have things we struggle with, but density, I'll read the definition for you here in a little bit, but some of what I'm going to show you is actually very, very simple once you kind of see what it is they're asking for. But we need to, I don't want you to be scared off by the word density to where you won't feel confident in answering the questions. So I've got this worksheet available here. What the concept here is we're going to apply what these concepts are of this thing called density, and it's going to be based on other things we should know about by now, area and volume, in these modeling situations. So maybe they want to know how many persons there are per square mile or BTUs per cubic feet. I always think, when I think of density, I think of like New York City has a very dense population. It's not, for the size of the city that it is, and it's a very large city, it has an enormous number of people that live or that will be in that city. So it's one of the reasons why coronavirus spread so much, is because without staying home, there was such a large possibility that it would be next to impossible to be socially distant, because there's just so many people in that particular city. So they would say it's a very dense population. Whereas Wyoming, it's like a desert out there. It's not very dense at all. There's miles and miles and miles of land where there's nobody that lives there. So we would say that's not very dense. So that's kind of where density comes in. Other times we can talk about the density of an object. They use an example here about a ping pong ball and a golf ball. I mean, and a steel ball, they could be the exact same size ball, but one may be way more dense than the other. You think when a ping pong ball is, a lot of it has to do with weight. So it's very lightweight, the ping pong ball is, and a golf ball is a little more dense, and then steel is very, very dense. So generally, the more dense it is, it seems to weigh a little bit more. But the reason why they don't necessarily always call it weight is because even though as far as we know, I mean, this is up for debate, but we may be the only life forms in the universe, but maybe there's some out there, who knows. But reason I mention that is that the weight of any of these objects on Earth is going to be different than the weight on other planets. So we don't always say weight, but what we can say is a little thing called mass. All right. The mass, the mass and weight are going to basically be the same thing as long as we're all talking about being on the same planet. But so there is a slight difference when they talk about this. So we're going to, density, as I mentioned, is a sort of how compact that substance is for the size of that object. And mass is the best way to think of it right now, is just the weight of the object. And then the volume is, how much, it's kind of like the area inside of that three-dimensional figure. We talk about volume of a cylinder and volume of a box and things. I always think about filling that box with something, but you could have a volume of any type of figure. In the previous video, we talked about spheres, we talked about cones, pyramids, and cylinders, if I didn't say that already. So if you have density and mass and volume, you can, there's a really nice little formula. And the only thing about this, though, is they don't give you this formula on the test. So you kind of at least need to know that if you know the mass and you know the volume, if you just divide those two, you will get this special thing called density. All right. So that's sort of the introduction of all of that. They said the basic relation for density is that density equals mass divided by volume, where M is the mass, or otherwise known as the weight, and then V is the volume. Density is defined, sorry about that, defined as the degree of compactness of a substance. How compact is it? They kind of go on. That's a little bit unclear sometimes. So let me turn my phone going off there. There we go. So let's look at an example. Again, there's three balls with the same size and shape, but obviously they do not have the same weight or density. The steel ball is very compact, so that's kind of what they mean by compact. It's not very hollow. All right. The ping pong ball is not compact at all. It's completely air inside. So we would say the steel ball is denser than the golf ball or the ping pong ball. Now, since this is kind of a density formula, but there are ways to solve for other things. If you knew one and not the other, you could solve for volume this way if you knew the mass and the density. So it depends on, if they give you two out of the three things, you could always solve it. These look like three completely different formulas, but it's all based on this one right here. So volume is mass over density, or the mass equals density times volume. So remember, if they're next to each other, that means multiply. A couple things here. Mass can be measured with different units. We measure things in the United States with pounds. Other countries may use grams, kilograms. We use ounces sometimes. But it says not comprehensive. There are many things you could measure things with, or there's different units you use to show mass or weight. Couple things they point out, you don't actually have to know this. This might be good to know, 16 ounces in a pound, just because that's pretty common here in the United States. But to know that a pound is 453.592 grams, I didn't even know that. So I guarantee they won't require you to know that. Other things I kind of mentioned here that's really important, when we are talking about volume, we're always talking about things in cubic units. So it might be cubic inches. If they're talking about cubic inches, they could actually write out the word cubic and the word inches, or they would have inches with a 3 as an exponent, because when you raise to the third power, that's called cubed. So that's where the cubic comes from. Cubic centimeter, or centimeters cube, or cubic feet. Feet cubed, cubic meters, meters cubed, cubic miles, miles cubed, cubic kilometers, kilometers cubed. All right. There's other conversions they mention here. This might be good to know, these two, but the other two, you don't have to memorize those. All right. here's kind of a density example here. If you know the density equals mass over volume, so look at the question. They are asking for what the density is. It's a golf ball. So golf ball, they don't say the name of the shape, but clearly a golf ball is what we call a sphere. And a sphere, the volume for a sphere, you would have to refer to your formula sheet, which again is available for you on the test. I'll write it down here, 4/3 pi r cubed. 4/3 pi r to the third power. That's the volume of a sphere. All right, that's the golf ball is in that shape. It tells you that it has a diameter of 1.66 inches and that the weight is 45.63 grams. All right, since the weight is 45.63 grams, that goes into the formula where the mass goes. Now, the tricky thing here is they give you diameter, and I showed you in the previous video how if the formula includes radius and they give you diameter, radius is half of that. So you can kind of see this sort of fits in there, but when you look back over here, this is where the 0.83 is. That's actually half of 1.66. So they kind of went to the final answer on this. Let me get a calculator up here. And your calculator is going to have a lot more options than what I have here. But let me see what I'm able to do here. 43.63. Then you can hit the divided by button. Then we'll do 4/3 divided by, well, what I would probably do is try to group that all together so it divides by that whole thing. So this will be on your calculator. You can hit the parentheses button. And then we could do a 4/3, which will calculate like that. Oops, let me fix that again, sorry. 45.63 divided by, let me do parentheses inside of parentheses. So calculate that. And then multiply that times 3.14 times 0.83 to the third power. Close the parentheses and then enter. Oops, yeah, it already calculated it before that. Oops, can I undo what I did? Well, I think hopefully you saw it. Maybe you could actually rewind, showing my age here. You could scroll back a little bit and see, I think I accidentally hit it twice. So 2.23 was your answer after you divided all that. Hopefully that didn't confuse you on the calculator that I had there, but pretty much what's happening, if I can get drawn again. You've got to make sure, your 4/3, you're gonna, I wish I had the other calculator, that would be great. One of these days I'll get it, but there's a button on the calculator that has it's a fraction button. So the button itself has a little thing like this. So when you hit that button, it allows you to type the top number and the bottom number, and then you've got like a little joystick thing that lets you sort of, hit, up, right, left, or down, so you could go down and then over to get out of that. We're back together. I'll be glad to show you in person how to do that. Anyway, it'd be 4/3 times 3.14, then times 0.83 to the third power. Now, all that's got to be together. So whatever this answer is, you got to do 45.63 divided by that. Clearly, you want a calculator for this. It would be a a lot of tedious work to do it all by hand. Okay, so now you can see why golf balls sink, because it's 2.23 grams for every cubic inch of that golf ball. All right, for this other example here, we've got some 2x4s, some lumber, 24 10-foot 2x4s beside his house. He wants to stack them on a shelf, but's not sure how much they weigh. So here they tell you the density. So if you know the density of the wood and you have enough information to figure out the volume. Yeah, this one's a little tricky. I don't know if I want to take a long time to do this because, you know, when they say it's a 2x4, well, we know that yeah, they're 10, we know they're 10 feet long, and then the other dimensions are 2x4, just like that's why they're called 2x4. So it's 2x4 by 120. So they figured out the 960 cubic inches there. So I'm actually going to skip this because I think that's beyond what you need to know. But you can pause and look through those examples if you want. Hemispherical tank. I'm not going to do that either because that's going a little bit, again, further than we want. This one here is at least one I've seen on a practice test before, so I kind of think that this is what the test may focus on. Other areas they're going to use density, not so much with an object like a golf ball, but now they're talking about, and one of the examples I gave was like New York City. It's something called population density. So how many people exist in every square unit of that land? All right. So they might have people per square mile. That would be a way to show population density, or how many plants per square foot, how many plants are in that city, or how many mice per kilometer. Don't want to think about that, but this is how you would write it. All right, population density informed us how compact the conditions. So for example, when you look at the chart below to get an idea of the diversity of living conditions across the country. So, you know, Philadelphia, you can kind of see, you know, if you've ever been there, that's a pretty big city. They said there's 11,233 people for every square mile. All right. Now, square mile would be where you'd be going 1 mile, one direction, like say I'm looking at a map and there's a square. So this is 1 mile and that's 1 mile. And of course that's 1 mile. So this would be considered a square mile. So all the buildings and the houses and people that could live within that area, they're saying there could be 11,000, a little over 11,000 people just in the little 1 mile by 1 mile area of the city. That's pretty compact, right? It's the population density is very, very dense. All right, very compact. Seattle, sort of a big city, but that's about almost a third what Philadelphia is. Still a lot of people, 4,722 people. And then, like I mentioned before, New York City, crazy, 27,000 people in every square mile. Like you can't walk without touching shoulders with somebody, it sounds like. I've actually not been to any of these cities. I've been across the country, but I don't think I've been to even any of these states. But yes, those are pretty dense. Philadelphia and New York City especially are pretty dense, but Anchorage, Alaska, it's a big city in general, but not a lot of people live there. All right. That's only 175 people per square mile. All right. So which city is the most dense? Well, clearly New York City. Now, if we these, you know, they kind of gave you those like they were already kind of done, but sometimes they could tell you how many people live there and then give you the volume, like what the area is of the city. And then from there, you can kind of figure out the density. So as long as you know density equals mass over volume, we could calculate it. But they were just giving you examples of what population density looks like and what it means. Let's see here. So they've got a, well, that's the one example I didn't really like. Okay. Population, this one, number 3, population of 578 honeybees live in a 1 acre area. So that's how you can kind of write this. You've got 578 bees per acre. They gather nectar from a population of 310 flowering plants, and the plants live in a particular section of that acre. So that's the density of the plants. Which population has a greater density, the insects or the plants? And so here's just a division problem, all right? 578 divided by 1 is just 578. And 310 divided by 0.2, well, you just plug that in, okay? 310 divided by 0.2, right? So it's 1,550. So the plants have the greater density because there are more plants per little section. Now, they did it kind of another way here where, you know, this one was in 1 acre. This was only 2/10 of an acre. So they wanted to know how many plants for every 1 acre. So they just, they sort of readjusted and multiplied the top and the bottom by 5 so that we could do the plants per acre. But otherwise, you could just divide like I did on the calculator. Try to find a calculate the density one. Okay, yeah, so number 6, Mike sold 3 board games on eBay to a single buyer. To save on shipping, he placed the 3 games into a single box with dimensions of 12 by 12 by 10, all right? This is not, since it's a box, that's just a box, that's gonna be just your length times width times height, all right? So those are one of those easier volume ones. They don't give that to you on the test, but since it's such an easy, just multiply all 3 without, you know, like you don't have to use pi or anything. That's one you'll have to know, all right? The box weighs 14.5 pounds. So to find the density, that's just however much it weighs divided by the volume of whatever the object is. So you have to know what shape you're dealing with. The mass is 14.5, and we're measuring it in pounds. And the volume is, you know, 12 times 12 times 10, all right? 12 times 12 times 10, you'll do on the calculator, it's 144 times 10, which I believe is 1,440. Trust me on that. And then we'll just do 14.5 and divide that by 1440. So, so it should be centimeter cubed. They wanted it in centimeters cubed. Okay, so 0.01 we would say pounds per cubic centimeter. 0.01 pounds per cubic centimeter. So when we go to the hundredths, there's tenths, there's hundredths. So that's a long number there, but we just stop after the second one. All right, that was found just by dividing. All right, I'm trying to see if they give us any other density ones. It's hoping to be density of something else. All right, I'll just use one more here. Okay, Jeff needs to move to Las Vegas, Nevada to Fargo, North Dakota. He decides to run a 20-foot shipping box. All right, shipping box is a rectangular prism, which again is just length times width times height. Generally, you're going to need that volume. You need to calculate the volume in order to calculate the density. So I just want to focus on density right now. Calls two companies to compare prices. Yeah, I mean, that's a good question, but I'm going to just focus on B for time's sake here. It's a 20-foot shipping box. Okay. So density is going to be equal to mass over volume. We know what would the density of the container be. Let's see here. Based on weight. Oh, yeah, this is where I kind of messed up. So we can really only do B based on what they said, letter A. I can't really skip A. So it's a 5,200 pound container here. So I needed to use that in the formula here. So the mass is 5,200 pounds. All right, and the volume is this times this times this. Now you got to be careful when it's 8'6". 6 inches is half of a foot, so it's 8.5, which can also be written as 8.5. So don't let that confuse you. 0.5 means half. 6 is half of 12. So if we're doing it in decimals, it's 8.5. All right, so 8.5 times 8 times 20. That's how you figure out the volume. 8.5 times 8 times 20. 1360. Okay, that's all we need. 5,200 divided by 1360. All right, 3.82. So it'd be 3.82, and we're measuring this in pounds per, the length was in feet, so cubic feet, they may write it like feet with a cube like that. 3.82 pounds per cubic feet is the density of the container. So it's pretty jam-packed. So for every 1 by 1 by 1 cube, it's going to be 3.82 pounds. It could be more. I mean, if you were shipping like, free weights or something, then obviously it could be even more. It would be very, very heavy, and then therefore more dense too. So obviously there's a connection between how heavy something is and how dense something is. Just like the different size, comparing the steel ball and the golf ball and the ping pong ball. So hopefully that makes sense when you're talking about density of an object, or population density was another big one. I was hoping I got more. This was the best worksheet I could find, but I really wanted more of the population density. Oh, you know what? I lied. I'm going to do one more because I see one that I think I need to do, and hopefully I apologize in advance. I've never done this one, so I'm kind of doing a shot in the dark here. Hopefully this is not too tricky. All right, we've got American bison population. Fluctuates means that sometimes it's 2,300 and sometimes it's as high as 5,500 animals in the two subpopulations. The northern herd breeds in one place, and on the high plateaus around it, central herd breeds somewhere else. Currently in Yellowstone National Park, the bison count is 4,750. If the park is 3,471 square miles, what is the population density of the American bison per square mile? Per square mile. All right. So in this case, when we're talking about population density, it's actually not mass over volume, it's mass over area, technically, okay? Because, square miles is an area. It's not, we're not talking about 3 dimensions. We're just talking about the land itself. All right, so they said this would be, and instead of mass, it's actually just going to be population. So how many people within that area. So this is just what we do for population density, not for density of an object. All right, so all we have to do is you got to make sure these numbers are in the right order. So if they say per square mile, we know that the square mile part is going to go on the bottom. So 3,471, and the top is going to have how many bison that there are. That's the population of the bison. Okay, so there we go. We just type it in the calculator, 4750 divided by 3471, and we'll get 1 point. I'm going to round that up to 37 bison per square mile. So square mile is going to have a 2, or they could say square mile like that. All righty, so there you have it. That's for population density. That could get you 1 or 2 questions there on the test. Every little bit counts. So give that a try on the quiz, and then I'll have a couple more for you tonight.